Right, those pesky rational expressions are not gone just yet. We are now going to be solving them with equations. So starting off this note, just quick review on our complex fractions and how to simplify those. Remember, I want to make the numerator and denominator a single fraction. So let's look at our numerator first. We need a common denominator. So between 4 and 2, our least common multiple is going to be 4. So to make that a single fraction, this already is the denominator of 4's. I multiply the second fraction by 2. And this is now x plus 6 over 4. There is my numerator. Now let's take a look at our denominator. 2 over 1 minus 3 over x. Our least common multiple here is going to be x. So I need to multiply my first fraction by x. And now I have a common denominator. And here is my denominator, and I know I'm eating up into some space, but I'm just going to keep working down here. So this is now x plus 6 over 4 divided by 2x minus 3 over x. So keep, change, flip. There are no factors for me to factor out or cancel, so I'm just going to have to multiply across. So I'll get x squared plus 6x over 8x minus 12. And that's going to be the final simplified complex fraction. All right, so now that that review is out of the way, we are now going to look at solving rational equations. So the way we do this is we have our original equation, and you start by multiplying each side by the least common multiple. So again, you're looking at your denominators. So in this first example, 5 and 2, my least common multiple here is going to be 10. So we're going to multiply by 10 on both sides. And what that's going to get us is 30 over 5 and 10x over 2. Then we're going to simplify each side. 30 divided by 5 is 6. 10x divided by 2 is 5x. And then we're going to divide both sides to get x by itself, and we find that x is 6 over 5. And you would plug that back into your original equation and see that it does check out. It is a valid solution. Okay, let's keep practicing that. Starting with example A here, we need to find our least common multiple. So I've got 8, remember this is 9 over 1, and 16. So my least common multiple on example A here is going to be 16. So we're going to multiply x over 8 by 16, 9 by 16, and the x over 16, negative x over 16 by 16. So all three parts get multiplied by 16. So 16x over 8 is equal to 144 minus 16x over 16. Then we're going to simplify and solve for x. So if I add that, we're going to get that 3x is equal to 144. Divide everything by 3, and we find that x is 48. And that 4 looks kind of funny, so I'm going to rewrite it. 48. Okay. Now let's look at B. My least common multiple, between 4, 6, and 2 is going to be 12. So we're going to multiply everything by 12. So 12 times x plus 1 over 4. X minus 3 over 6 is also going to get multiplied by 12. And 3 over 2 is going to get multiplied by 12. So we're going to get 12x plus 12 over 4 minus 12x minus 36 over 6 is equal to 36 over 2. So let's factor our numerators here. I've got 4 and 6 as my denominators here, so I can actually factor out a 4 from the top. That'll leave me with 3x plus 3. And I can factor out a 6 here, and that'll leave us with 2x minus 6. So now I can simplify each of those. So I get 3x plus 3 minus that 2x minus 6. We can't forget to distribute that negative, and that's going to be equal to 18. So continuing to do this super basic algebra stuff that we've been doing for what seems like ages now. 3x minus 2x is going to leave us with x. 3 plus 12 is 15. I'm sorry, that's not 12. That should be 6. I don't know what I was doing there. Negative times negative 6, that's going to be plus 6. 3 plus 6 is 9. So then we subtract that, and we get, oops, sorry, you haven't been able to see that. X is 9. I'm going to pause on that work for here just a second. If I can get it to focus. There we go. So we distributed that negative. So 3x plus 3 minus 2x plus 6. Combine our like terms with our x's and our constants and find x. Last one on this front page, example C. Still looking for a least common multiple between 3, 2, and 6, and that is going to be 6. So everything gets multiplied by 6. So we get 6x squared over 3 plus 6x over 2, 30 over 6. So let's simplify. This is going to give us 2x squared plus 3x is equal to 5. So we have a trinomial here, a quadratic, so we need to get everything on the same side. And we are going to need to factor. So that's going to give us 2x plus 5 and x minus 1. So setting each of those parentheses equal to 0. We are going to get two solutions. We're going to get negative 5 over 2 and 1. And if we plugged both of those into our original equation, they would check out as valid solutions. Okay, on to the back. So now, that was with constant denominators, meaning we had just numbers. Now what do we do when we have variables in the denominator? It's the same process. We're still going to look for our least common multiple. It's just now also going to contain some variables. So let's find our least common multiple in this original equation. I've got x, 3x, and 3. So that least common multiple is going to be 3x. So we'll multiply by 3x on both sides. And so here on the left, that's going to give us 21x over x minus 3x over 3x. And on the right, we're going to get 24x over 3. So now let's simplify. So 21x over x, that's just 21, minus 3x divided by x is 1. 24x over 3 is 8x. So that's that 20 is equal to 8x. Divide by 8. And we find that x is equal to, we can simplify that to 5 over 2. All right, so on to more examples. D here, 25 minus y and 4. That least common multiple, as ugly as it's going to be, is actually going to be 25 minus y times 4. So we're going to multiply both sides by this least common multiple. So 25 minus y, 4 gets multiplied by 9 over 25 minus y, and negative 1/4 also gets multiplied by this nice, ugly least common multiple. So I'm going to go ahead and start canceling common items. So this 25 minus y is going to cancel here, and I'm going to be left with 4 times 9, which is 36. And here this 4 and this 4 are going to be canceled, and we're going to be left with negative 1 times 25 minus y. So we have to distribute that minus sign. And then to solve for y, I just need to add 25 to both sides. And we get that y is 61. Okay, let's keep practicing. I'm going to erase that just so I'm not intruding on the space for example E. Least common multiple, I've got x, x minus 2, and 1. So that least common multiple is going to be x times x minus 2. So everything gets multiplied by x times x minus 2. So on this side we've got 2 over x. We've got 3 over x minus 2 minus 1 times x, x minus 2. I'm running out of room, I'm sorry. But okay, So we've got 2 times x minus 2 over x is equal to 3 times x minus 2 over x minus 2 minus x times x minus 2. So here I can cancel an x. So that leaves me with 2 times x minus 2. Here I can cancel x minus 2. That leaves us with 3x. And then I can distribute this negative x here. Negative x squared plus 2. Now I need to distribute that 2 on the left. So 2x minus 4 is equal to 3x minus x squared plus 2. And hopefully you're already recognizing that this is going to be, oh, that should be x, sorry. This is going to be a quadratic, so I need to get everything on the same side. So I'm going to move this 2x over and the 4. And so 0 is going to be equal to minus x squared plus 3x plus 4. Now, I don't like that negative being in the front, so I am going to factor it out and change the sign of everything else. Now I'm ready to factor my quadratic. So factors of negative 4 that add to negative 3 is minus 4 and plus 1. So if x minus 4 equals 0 and x plus 1 equals 0, our two solutions are going to be 4 and negative 1. And last but not least, on f, my least common multiple is going to be x times x minus 2. So on the left side, 10 times x minus 2 over, it's already over x minus 2. Then 4 times x minus 2 over x is equal to 5 times x minus 2 over x minus 2. So I can cancel everything here on that first fraction, and I'm left with 10. On the second one, I can cancel my x's. And on the right side, I can cancel the x minus 2's. So let's distribute that 4. Let's simplify. 10 minus 8 is 2. Move that 4x over. And we get that x is equal to 2. But let's look at what equation we started with. If I plug in 2, I'm going to end up with 0 in 2 places in my equation. So that doesn't work. So this question has no solution. All right, and that is it for our notes on day 1 of rational equations.